we really are at the end of this journey. At the end of this journey, well, like every scientific paper worth its name, we got to end up with a bunch of open questions, right? Otherwise, it doesn't make sense. So, if you remember, I told you what it is, what the package is probably going to look like. I don't know how, I don't know when, but we are slowly going towards this shape. I hope we have convinced you that it does make sense. Everything here makes sense. It makes sense because learning in model logic gives you more information, because it is possible, because we show this on real data, because we have a complete package that works from start to the end, and somehow also because the community appreciates that. We got already published a bunch of papers on this, some of them in some pretty good venues like the Journal of Artificial Intelligence in Medicine, or PLOS ONE, for example, which is a non-mathematical and non-computer science journal. It's in general, it is in the same category of science or nature. Of course, it's not the same quality, but it shows that the community has some kind of interest in this, even in the era of neural networks, and we like to think that we can keep going on in both on both directions at the same time. The one in which we push it from the learning point of view, and the one in which we push it from the logical point of view. In particular, because our models are so expressive, they give you so much logical information, you can do a bunch of things with them. You can discuss like we did. You can look at them, and then you can ask for minimizations of formulas. You can ask for explanation, which is a logical concept. I'm learning this in these days. This is one of the reasons I'm here. And you can you can do a bunch of things on it that you couldn't do on other type of models. You can mix them up with neural networks. You can mix it up with non-symbolic, in general, non-symbolic models. If you think, as I mentioned before, if you think about a non-symbolic model as just yet another feature extraction function, just throw them in the mix, and you get a neurosymbolic hybrid. Because our ensembles are ensembles of logical things, like they are in the propositional case, you can work a new theory about extracting how do we extract formulas from an ensemble? Of course, the problem already exists at the propositional level, and of course, it has been attacked somehow. We actually did already kind of some work on this. I think in this year, ECI, we published one paper about extracting formulas from, in our case, but it was an early approach, a very naive approach of how to extract rules. And the more expressive is the logic, the more interesting this problem become. So this is why I mention it here. And of course, as I said at some stage, if you're doing logic, then you can do fuzzy logic. And if you some of the symbolic method already exists at the fuzzy level. That of course, and I mean, one thing is to say it, another thing is to have it in the real world. Which is to say, if you look for fuzzy decision trees, you will find out, I don't know, maybe 10 or 15 papers in the past 20, 30 years. But then if you go to the packages and see which package does offer me a fuzzy decision tree for my data, probably the answer is 0 or close to that. So, which is to say, from theory to practice, there is a very big step, and it's not always easy. And this is some other things that we are looking into right now. So this isn't the end of journey. The end of the journey. This is the beginning of a journey, which we are really proud of having started. There's a bunch of people that contributed to these ideas. I will list some of them here. I think I mentioned this. Our lab has, in our lab work undergrad student, grad student, PhD students, postgrad student, all of them together in the same room. Of course, we don't have the same facilities and the same power that exists in a big university like the University of Sydney. But yeah, we're trying to do the best we can with what we have. We are so lucky that we work also with the private sector. So sometimes we get some help from it. And yes, of course, I want to thank all Mauro, Michele, Lorenzo, Federico, Edward, and Patrick. These are mentioned here because they have actually written part of the code at some stage, and they all still work in a lab in one way or another. And there are another bunch of people that's not mentioned here that also gave their contribution, but in some other way, maybe only theoretical, maybe because they have done their undergrad final project. If you go to the web page of our lab, you'll see the complete list. I'm also proud to say that people that work with us usually get to be published even in a very, very early stage of their career, like undergrad, for example, because we think in that way. And of course, I want to thank Sasha for inviting me here. It has been the nicest experience, professionally speaking, that I remember in a long time. This place is absolutely fantastic. You make it so. So thank you for being here and for bearing with me, with us all this time. I really open up. I'm really open to collaboration in any level, data level, machine learning level, theoretical level, whatever. I mean, this is what we do, and this is our job. We have limited time, but with that limited time, we do the most as we can. I think that with Sasha, we started, I don't know how many different lines in a few days. So please reach out in every possible sense. I mean, you want to collaborate in any possible case, remotely, in Italy, here, whatever, because this is what makes everything interesting and fun. And again, thank you for this. It has been a great pleasure being here. I hope it wasn't, it was good enough for you guys, and let's see if we can meet each other again. Okay?
Thank you.
So thank you.